Today, we will learn about what a function is. You'll be given a few examples for practice. Please feel free to pause and rewind at any time during this video. So, what exactly is a function? A function is a relation between a set of inputs and a set of possible outputs, with the property that each input is related to exactly one output. Now, that's a lot to take in. So let's say what a function is again, but in a different way, okay? A function kind of works like a machine. Let's call it a function machine. Our machine, we will be able to put things into it and get things out. So, we'll be able to put material into our machine, and then we'll be able to put material out. The material will come out. The X represents the material that you actually put into your machine. So that will be called input. The stuff that you put out of your machine is actually called output. And that is actually the Y value. But since we're learning about what a function is, the f of x is an actual function. So these parentheses represent our function machine. This x is our input, what we put into the machine. What comes out are our y values. So this actually equals y. F of x equals y. This is a very important equation when learning about functions. So a function is something that has inputs and outputs. But there can only be one input for every output. For example, let's say we have an apple. So I'm going to draw an apple. Our apple represents our input. So we're going to put our apple into our function machine, And then what we get out is our y. And let's say it's seeds. Let's say we get out seeds. So I'm actually going to use purple here. Let's say we get out seeds. So that means we get out seeds over here. So our input is the apple into our function machine, and our output is seeds. So the function that we see here, f representing the function of x, is y. I will say that one more time. The function of x is y. The function of an apple is seeds, produces seeds. What if we have an orange? Let's say this is an orange, okay? So an apple goes in, produces seeds. An orange can also go into the function machine and produce seeds again. But what cannot happen is if I put an apple into the function machine, my output's already seeds, so I cannot get an orange. I cannot get an orange here. Okay? So if I put an apple into the machine, I must get out seeds. I must get seeds out. But if I get out an orange instead of seeds, that means that's not a function. So what does this mean? This means that every time I put an apple into the machine, I must get out seeds. But if I get out something else, that means it is not a function. So let's take, instead of an orange, let's take a red apple and a green apple. Let's say this is a green apple. They're both apples, right? So if I put the red apple in, what should I get out? If you said seeds, you're correct. Again, this is an apple. So if I put an apple into the machine, what should I get out? If you said seeds, good job. They're both apples, so I should both get seeds out. If I put this red apple in and get out seeds, and I put this green apple in and get out an orange, could that be a function? Pause and think about it. Welcome back. If you said no, you're correct. Remember, if I have the same input, I must have the same output. As long as my outputs match my inputs, I'm good. How about if I have an orange? The same example we've been using. If I put in an orange, I can also get out seeds. It is okay to have the same output for different inputs. But it is not okay to have different outputs for the same input. It is not okay. So let's actually use an example with a T-chart. So I'm going to erase our function machine, but we'll keep our actual function machine equation up here. So, drawing a T-chart is when we have our input values on our right-hand side, and input values represent our X values, and then we have our output values on our right-hand side, which represents our Y values. Or in this case, what does Y equal? F of X. So we're actually going to put F of X right here instead of Y. They are the same thing. F of X is, that's what the equal sign means, is Y. So we can interchange these two, meaning if wherever we see Y, we could put F of X. Wherever we see F of X, we can also put Y. And it's called a T-chart because it looks like a T. So, let's draw a couple lines. What I will do is I will randomly choose numbers. Any numbers you want. I'm going to randomly choose them. I'm going to make these lines a little more distinct. So let's just say for my input values, what's going to be going into my function machine, I choose, let's say, 0, 1, 2, and 5. Where did I get these numbers? I pulled them out of a hat. I randomly chose these numbers. They have no significant value at all. The numbers I'm going to write over here, they have no significant value at all, except for this will be an example of what a function is. So I'm creating these numbers so that you know what a function is. Okay, so this is an example of a function. So if I take this input and I put it into my function machine, my output will be 2. My output will be 2. If I take this input, 1, put it into my function machine, my output will be 3. If I take this input value and put it into my function machine, my output will be 4. Last one, if I take this input 5 and put it into my function machine, my output will be 3. Now, I already told you that this is an example of a function, but someone may be asking, hey, I see a 3 right here, and I see a 3 right here. Well, there are 2 different inputs. So let's say a red apple, and let's say an orange. Okay, this is an orange, it's green, but it's still an orange, okay? Trust me. Okay? So, this apple goes into the machine and produces seeds. But this orange goes into the machine and also produces seeds. That's okay. You can have 2 different inputs with the same output, but you cannot have the same output. So if this right here, no. If this right here was a 1, so that means this was an apple right here as well, I cannot have the same input with 2 different outputs. That means it is not a function. I cannot have that. These outputs have to be the same if this input is the same. It's okay for them to be different and have the same output, but it is not okay for them to be the same input and have different outputs. This is not okay. So that was actually an example of not a function, but I'm going to give you a real example of not a function, because that was actually our example of a function. So drawing another T-chart. Okay, so this is example, this is not a function. Okay, so again, I'm randomly choosing these numbers, 1, 1, 2, 3, okay? Let's do the same exact thing as we did. Take this input, put it into our function machine, and get out a 2. Take this input, put it into the function machine. Let's say we get out a 5. Uh-oh, back it up, beep, beep, beep. Pause and tell me what happened here. Welcome back. If you said that this is not a function, which it's not, because I said it's going to be an example of not a function, you're correct. I want you to tell me why. Why? Why isn't this a function? I'll go ahead and write some numbers over here too. Why isn't this a function? Well, we have an apple and we have another apple. One produces seeds and the other produces a marker, or let's say a crayon or something, a pencil. That doesn't make sense. That doesn't make sense. If they're the same input, they have to have the same output, but they're different. So that's why this is not a function. So the outputs must match the same input. So now you're going to have an opportunity to determine whether or not we give you a T-chart. You're going to have the opportunity to determine whether or not it's a function or if it's not a function. If it is a function, just say yes. If it's not a function, you're going to have to give an explanation. So, quick review. A function is written like this. Function of x is y. This is written like this. A function of x is y. So this statement in English is this statement right here in math. These are the same exact statements, except this one's in math language and this one is in English. The function is this f of x, of is the parentheses, x the input value, is the equal sign, y, our output value. So this is what a function is. For every input, there must be exactly one output. So every x must have at least one output. This x cannot have two outputs, only one. Move on to the next slide and complete the examples.